Hello everyone, welcome to tutorial 10 of the CAD course. In this tutorial, we'll continue to make assemblies, and as you can see, we have 14 parts available to you in Blackboard, so you don't need to create the parts, but you have only to develop the assembly based on those parts. So if you go to Content, Tutorials and Tutorial 10, you can download the parts, and then your task will be opening SolidWorks, New Assembly, and assemble the parts together. In this tutorial, we'll go through the whole process of making assembly, starting from fixing the home view, checking interference between the parts, creating exploded view, making a video animation to rotate the total assembly or explode the components and collapse the components back to the assembly. We will also learn how to create 2D drawings for parts or for assembly. Now, let's go to the file. And this is the mechanism that we want to create. It is an electric saw machine. As you can see from both views, we have the saw mechanism, electric saw mechanism. That means we have electric motor for the rotation, and manually I can take this saw down or up if I want to cut some material. Okay. Now the exploded view will look like this. So I want to show the users how the mechanism will work or how to assemble the mechanism. And I'm having all the components, all parts together with labels. So label number 1 is maybe the main blade holding the mechanism. Number 2 is some rotating blade. Number 3 is the bath of the saw in which it will come inside to cut the components, and so on. So I need some table to explain the numbers, those labels. If I go down, I will find the bill of material. So it says number 1 is the base, that is the base. Number 5 is the bearing holder. So if I go to number 5, I will see that I have this mechanism, this holder to fix the bearing, which is taking this shaft for rotating the whole components, and so on. So from the exploded view, I can get the detailed view of how the components are attached to each other. This full view shows the mechanism in general, and the bill of material will show the components with details, maybe quantity, maybe material, colors, and other descriptions. Good. We can also, after we finish the assembly, we can develop some video to show the animation to further explain how the machine will work. So I already have this machine, and if I run this video, you can see that the saw is rotating through the belt mechanism, and it can come down so that it will cut the elements available in the saw machine. Okay, this video is not perfect because the belt is not included in the rotation, but in general we make video animations to show users how our machine is going to work. Now let's go and download the files and start the assembly. When you download the files, it's always useful to have them in one specific folder. So as you can see, I have this folder for tutorial number 10, and I have listed all the parts. Of course I did the assembly, but we are going to make it again. I can right click, view large icons, so you can check exactly the view of each component and the name. So for the base, this is the view of the base. This view will help me while selecting the components in the assembly. But in general, if you know the names, you don't need to look at the shapes. But it's always better for me, I think, to check the name plus the photo. Now let's go to the software and open new file, of course assembly, and automatically it will open to me the browse folder. So the first time I open an assembly, it will open this folder to me. For any reason I cancel this, I can go back for the insert components icon, and I can go for browse, and I will find all the components. Now Before we start the assembly, let's try to find some basic component that everything will be attached to it. In the PDF file, we can see that this plate is the base of everything. And by the way, that is the name. So when we say base, it's the basic element. Of course, I made those names depending on the component, and I know that this is the base. But for you, for example, if you have different names, you have to look at the drawing and decide which one to be the base component. Now, always when you select the components, start with the main component, which is the base. If I click on the base, and of course remember that you can control the views, so show large icons, and then I can check which component. It's easy for me to find the base. This is the base, and open. Now I have the base and I can drag it anywhere in the assembly screen, and I'll just click in this location. Now once I put the component, you can see that it came normal to the home view, and it's zoomed in a way that it will fill the screen, and I cannot move this component. Remember that we decided this to be our base component, and SolidWorks understands this, and it will put the first component as a fixed component. So if you check this name, it says base, which is the name of the part, and it says F. That means this component is fixed. If I click anywhere on this part, it will show the same part on the components tree. If I click on this part, it will highlight the whole part in the assembly page. Okay, now in general, the whole assembly contains many part components. So we have only one single part now, that's why I have only this part. Now, can I move this part? Yes, of course. I can right click on this part and make it float. So it's moving now. I have the freedom to move it. If I right click on the same part on the component tree, I can also have the fixed component, so it will not move anymore. Now, let's check the home view. View orientation, as we did in parts. If I click this icon, isometric, it will show me the view, and you can see that it's exactly similar to what we have in this page. So for any reason, if I want to show a different view, I simply need to go and rotate this part, and I can say show me this view. The problem is, once I go back and check isometric, it will go back to the original shape. Now, one option is to move components and rotate components. I will click on rotate, and if I rotate this part, now it will not rotate. Why? Because it was fixed. So fixed component means it's not allowed to move or rotate. If I want to move it, I have to go and make it float. Now in this case, I rotate the component easily. Now what is the difference between rotating the part itself and rotating the whole view? Now I'm rotating a specific part, and I will say confirm. This is rotating the whole view. Now if I go back to the isometric view, it will show me the last orientation I made randomly on moving or rotating the component, which is not true now because it's not similar to option 1 or option 2. So I don't like this manual rotation to fix the view on a specific orientation. So I can do it manually, but the issue is once I go back to the isometric view, it will show me a different view, and I don't like this. So how to fix the home view? The proper way is to look at the top view of this part and mate it with the top plane of the assembly file. So this assembly file, it has front plane, top plane and right plane, and they are sharing the same origin of the assembly. Now, the one who created this part, he also had a front plane, a top plane, and a right plane. Now, what if I say this part is the base element, so I want to fix its view to match the home view of the assembly? Then simply I can use the mate component, and I'll say this face of the part should mate the top plane of the assembly. How I can do that? I'll just go to mate, and it asks me the mate selection. I'll say this face, for example, and now I can see that I'm dealing with the mate conversation tab, and I cannot see the list of components tree I had before. So if I cancel this, I will see the tree. If I bring the mate, it's not shown anymore. But if I click this icon, I can see the whole components tree and I can select anything I want. Now remember that we wanted to mate this view with the top plane of the assembly. And that's it. So we did. And I have to confirm. Now, I want to follow the first orientation. So this is my front view. So I have again to select this plane as a new mate and mate it with the front plane of the assembly. And then I have to confirm. And finally, I can say this plane, for example, to be mated with the right plane, and confirm, and that's it. In this case, if I click on the isometric view, I will find the proper desired shape. Okay, so that is the first part of making any assembly. You have to fix the home view. Now, can I move this part? No. Is it fixed? No. Why it's not moving? Because I created a relationship between 3 planes on this object with 3 planes on the assembly. So it doesn't have the option to move at all. So it's equivalent to fixing the part, but I made the fix with proper orientation to match the home view requested in the question. Okay, so this is our first component, which is the base. Now, I can go back to the PDF file and think about the second component to be placed on the assembly. I can see that on top of the base, I have this round shape, and for details, I can go to the exploded view. So this number 1 is the base, and this is number 2. So number 2 is the rotating plate. Now I can go and insert components and find the rotating plate. So this is the rotating plate. I can open and bring to the assembly. Again, this component is free to move, and I have to attach it to the mechanism. So these 2 cylinders should match each other. I can say mate the surface of this cylinder with the surface of this cylinder. Basically, I'm mating the axis, not the surface itself. So this is a cylinder with a center line, and this is another cylinder with a center line. If I confirm this, and by the way, you can check the type of the mate is concentric. It's not parallel, it's not perpendicular, it's not tangent, it's not coincident, because they cannot. They have different diameters. But it's concentric. That means they share the same center line. If I confirm this mate, and close the tab, I can see that this blade, circular blade, can go up and down, but I cannot move it to X or Y components. Now I have to fix the Z axis movement, and I know that the bottom surface of this blade should mate the top surface of the other blade. Now if I go to mate and select surface with surface, and this is coincident, that means they match, they touch each other, and then I have to confirm and finish. So this blade cannot move in X or Y, I cannot move it in Z axis, but still, because of the concentric mate, it can rotate, and this is part of the mechanism, because I can rotate the saw to cut in different angles. So this blade will rotate, and then the saw will make the angle. So we are done with the second part. Now again, you have to go and think of the mechanism. I think the proper element to be added is this rectangular blade. So let's check for the exploded view, and it says part number 3, and the name is saw path. So insert components, browse, and it's the saw path, and open, and I have to bring it to the assembly. Now again, this part is free to move, and always I have to mate the components to have a fixed relationship, so one part will not move randomly. Now the best thing to start with is mating this surface with this surface. So if I go to mate, plane 1 with plane 2, and confirm and finish. Now you can see that this part in Z axis it cannot move. So if I show you the right plane, this part cannot go up and down because I forced the two surfaces to be mated. But this part can move in X axis, and if I show you the front plane, this part can move in Y axis. So I have to add another relationship to fix the movement of this component. Now I think the path of the saw should be exactly in the center of this part, because when it rotates it will be exactly in the center. So if I can create a relationship that makes the center of this part with the center of the distance between element A and element B. So how I can do that? In this case we have to learn about mating planes. So if I want to mate, for example, this surface with this surface, that's easy. But the issue is this mate is not in the center. So it cannot move in X axis, and now you can see that they are attached to each other, but they are not in the center of the plane between element 1 and 2. So this is not a proper mate. How I can delete this mate I did earlier? Now I have two options. If I click on mates at the bottom of the assembly, you can see that I have part 1, part 2 and part 3. If I click mates, it will show me all mates I did before, and it's difficult to identify a specific mate if I have more than 5 or 15 components. So I don't prefer to go and edit mates or delete them from the mates list. Instead, I can click on this part, and I know that it's saw path, options, mates. In the assembly I can see only two mates. One of them is the two surfaces, the orange with the purple, and this is the mate I want to delete, so right click and delete, and yes, confirm. Again, it's moving in x-axis. So how to decide this specific distance to be in the middle? Let me show you the top view. How to decide if this part is exactly in the middle. Now, what I can do is creating a new plane in the center of this distance. So initially I have to go to evaluate and measure the distance between part 1 and part 2, face 1 and face 2, and you can see that the black color is 2 centimeter. So this distance is 2 centimeter, and I can go now to assembly and reference geometry and plane, and I can say the reference is this face, and I want to create something new at a distance of 1 centimeter, which is the middle of the total distance. It was 2, so the center is 1, and then confirm. So you can see that I have plane number 1 available in the assembly. Now, this part, which is the saw path, it has front plane, top plane, and right plane. Now, luckily, the right plane of this part is in the middle, so I don't need to create a new plane. I don't have to measure the distance and create a reference plane from this surface to the center. So I can use the right plane of this part to be mated with plane number 1 I created between the two elements. Okay, so if I go and mate, now I don't have the options, so I have to go and find them. I know that, let me just zoom this, the saw path, the right plane, should be mated with plane number 1. It's at the end of the assembly because I added this plane on the assembly. It's not part of any single element. So that's plane number 1. So I'm mating right plane of the saw path with plane number 1, and if I confirm, you can see that from the top view this part is not moving in x-axis, and we only have freedom to move in y-axis. So how far this element can move from the two joints. And again, I have to create a relationship or a mate to fix the movement in this axis. Simply, I can say mate and connect this surface with this surface, and they are attached to each other. Okay. You can see that our previous mate is perfect and everything is in the center, and this part is not moving anywhere, but it's connected to the rotating blades. So if the blade rotates, everything will rotate as one single mechanism. Now, if I have specific dimensions, it should be given to me in the drawing itself. So if this part is not attached, for example, let me zoom. If this part is not connected to the blades, as we can see in this photo, then the question will tell me, or if I'm the designer, I have to decide the exact distance. So for now, I can assume that they are connected to each other because it will not affect the assembly, or I can do something else. I would say the last mate I did, which connects this part, so mates in the assembly, and the last mate I did, this one, I want to edit this mate, and I have to add a distance. So the distance between the two mates, between the two surfaces, is 0 centimeter. What if I make it to 1 centimeter? Okay, I think this is okay. and it looks similar to the one we have in the PDF file, so I will confirm. Remember that if you have instructions, then you have to follow. In this case, I don't have specific details, but if I have in the drawing files that this distance is 2 centimeters, then I have to add the distance of 2 centimeters exactly as requested. Now, we are good. If I go back to the home view, I'll get this, which is very good. Now, what else? Think of other components that I can add. Maybe I will add this small shaft connected in the two holes in the two components. Or maybe I can add the blade and the motor and fix them as one unit. So let's go step by step and let's add the shaft, the small shaft. But sometimes you will be confused if you have many components, looks like a shaft. So is it saw shaft or bearing shaft? The best way to check is to go back to the explored view and find the name. So this is part number 4, which reads the bearing shaft. Then I have to go to components and browse the bearing shaft and open. Good. By now you should know how to go to mate and select the axis of this shaft to be mated with the axis of this cylinder, so they are similar, and this shaft is free to move while in the same axis. Now look, anytime I'm moving this shaft, the whole blade is rotating, and I don't want this to confuse me for now, so I will assume that this part is fixed in order to give me the freedom to control the shaft movement properly. And I think this shaft should be in the center. So again, I can use the same method we did earlier of making planes. So I can make a new plane in the middle of this shaft and mate it with the plane we created earlier, which was plane number 1, I guess. So if I reduce this component 3, plane number 1 is something in the middle. So let me check this shaft components, and the front plane of the shaft is there. So I cannot find a ready plane available in the center, but easily I can evaluate the distance between this surface and that surface, and it's 5.85 centimeter, and then I would create a new plane parallel to this surface at a distance of 5.58 divided by 2 and flip opposite direction, and you can see that it's in the center, and finish. Now if I mate plane number 1 with plane number 2, this shaft will be placed in the center. So let's go and mate plane number 1 with plane number 2. Now we have a small problem in here, which is we cannot mate two planes available in the same assembly. Let me cancel this. So as you see, plane number 1 belongs to the whole assembly, plane number 2 belongs to the whole assembly. I cannot create a mate relationship between the two planes. So what I can do is I will delete this and open this shaft, and I can create a new plane in the part environment. So again, if I want to check the height of the plane, it was 58.5 millimeter, and features reference geometry, plane parallel to this, and 58.5 by 2 millimeters in the other direction, and confirm and save. Remember that this is plane number 1 in this specific part, and save. And yes, so it's updating everything in the assembly. Now I want to make plane number 1 on the assembly with plane number 1 on the shaft. So if I go to mate, components, plane number 1 on the assembly with plane number 1 on the shaft, so they will mate and I can finish and confirm. So this shaft now is exactly in the center. It's free to rotate and for now it's fine, but it cannot move in any other direction, X, Y or Z. Now let's go and bring something new. I can place the bearing components. I have bearing from one side and a second bearing from the other side. If I want to check the details, because maybe bearing number 1, 2, 3 and 4 are different, so I don't want to get confused when I find bearing holder and I'll discover later that this size is not suitable for the bearing shaft. So the best option is to go and check component number 5, which is the bearing holder, and I have 4 quantities. That means the same bearing is used for the 4 components in the assembly. So the bearing shaft. Now let's go place component and find the bearing holder and place 1 in here. I need more bearing component, so I can again go to insert components, browse the bearing holder and open and put there. If I want to copy components, I can control and drag. That's how the copy paste work in SolidWorks. If I click and delete, it will be removed. So how we can fix the bearings? We have to go to mate, axis of the shaft with axis of the bearing. That's relation number 1. And then this bearing is moving, and I can say mate this surface with this surface and then confirm. Again, this is approximate, but if I have exact detailed dimensions, it will tell me exactly how is the distance between bearing and shaft in terms of y-axis. So let's go and make the other bearing. It's axis with axis, and then this surface with the shaft surface and confirm. Now the orientation, if I check the home view, the orientation of those bearings are something like this. Why? Because we need to fix the blade that will rotate through this shaft. So let's check again the assembly, and I have this blade. It's clear in the right photo. So this L shape, this blade is mounted on top of the bearing. If I go to the Explorer view for more details, I can see that blade number 6 is attached to the bearing, and number 6 is named as blade. So insert component and find the blade. This is the blade. Open and place. So what is the proper orientation of this blade? Of course, I can rotate this component to the right and left until I get some approximate view as it looks in the assembly. So I think this is the proper orientation. So it's an L shape. It's an L shape. So this is a good view. And then confirm the rotation. Now, the bottom surface of this blade is mated with this bearing. Good. But it's not only on a single bearing. So this part will be attached to the two bearings. What I can do is I can relate the movement of bearing 1 with bearing 2 and make them coincident. That means they have the same plane all the time. So if I rotate bearing 1, both of them will rotate, and because I attach the blade to bearing number 1, it will also rotate with bearing number 2, so 3 of them has the same angle always. Now I fixed only one single axis, which is the z-axis. Now if I look on the top view, this plane can move in x-axis and also can move in y-axis because I only fixed the z-axis. So what I can do is I can go until these 4 holes on the bearings match the 4 holes on the blade, and I can fix them together. So that's one single element. Now how to do that? I can just find the 2 holes approximately close to each other. I can mate. Now this edge on the top surface of the bearing should mate this edge on the bottom surface of the blade, and they are attached to each other now, and confirm. Let's check the movement now. So this blade cannot move in X or Y because it's attached to one single edge on the bearing. How to fix the other one? I can select these 2 holes or these 2 holes or these 2 holes to confirm the motion, and finally mate top edge of the bearing with bottom edge of the blade, and they are connected, and confirm. And you can see that the blade cannot move anywhere. The only movement now is the rotation of the shaft. So the shaft is rotating and the blade is connected to the 2 bearings. Good. Now what else? If I go, I can see that this blade is holding the motor. So if I bring the motor, there is no need to check the explode view for the motor name, so it's number 8, and number 8 shows a motor, and I can go insert component, find the motor and open, and it's connected. The only thing I have to do is the orientation of the motor. If I check the home view, this direction is not proper now because the shaft of the motor is connected to this pulley system on the shaft, and it's not on the left side, it's on the right side. So what I can do is rotating this motor to the proper direction, and I can see that the motor itself has 4 holes to be connected together with the bearing and the blade. And you can see that SolidWorks is asking me to save the file, and it's giving me a reminder from time to time, so it's better to Control S and rebuild and save the document, because if I lose my work, it will not be recovered without saving. So I have to save the assembly, and usually it's preferred to have the same folder, tutorials, and this is tutorial number 10, and this is, we can say, SAO mechanism, MM, and save. So instead of assembly 1, you can see that SAW mechanism. Okay, now everything is saved. From time to time I have to Control S to update the saving. Now for the motor, I can see that I have 4 holes matching the 4 holes for the bearing and the blade. Simply I need to connect edge number 1 with this edge, so the motor is connected to only one edge. If I rotate the motor, it can rotate, so I have to find another edge, maybe this one. So this edge to be mated with that edge and confirm. So the motor now is connected to the blade, and it will rotate with the whole mechanism. Good. What we can do now is adding the first pulley to the motor. Then I have to check for the name, number 9, the motor's pulley. Good. SolidWorks, insert component, and show the large icons, and motor's pulley, open. Good. I have to mate axis with axis, and surface with surface. Now always shaft mechanisms, they have some space between the element and the shaft, so it's better to keep a distance. Maybe this is 0.1 centimeter, 0.2 centimeter, that's fine, and then I have to save and confirm. Now what is the next element that we can add? If I look at the tutorials, so I have to connect the 2 bearings and the shaft and the pulley system. So let me find the second shaft. Before that, let me find the bearings, 2 bearings, and it's better to check the orientation. So these are the 2 bearings. So what I can do, I can insert component and browse for the bearing holder, or I can simply copy this. So control drag for bearing number 1 and control drag for bearing number 2. Good. The orientation of the 2 bearings will be something like this. Let me rotate the bearing components. So this is bearing number 1 and confirm, and also rotate the second bearing. This is bearing number 2 and confirm. Now I have to mate the bottom edge of the first bearing with this edge on the blade, and of course this edge on the blade with that edge on the bearing, and they are matching. I also need to add the bottom edge of the bearing with the top face of the blade. Mate number 1 and automatically I have to connect edge 1 with edge 2, so everything is fixed and perfect. Good. Now I have to add the shaft that holds the saw, which is in the tutorial. It says number 7, the saw shaft. So insert component, saw shaft, and it has two sides. One of them is threaded, and that's because it will connect the nut on the left side, so the right side will not have the thread. Then if I rotate this, it will look good, and then I can mate the surface of the shaft with the surface of the bearing, and that's number 1. Now what I can do is mating this surface with this surface to be exactly in the same location if I look from top view. So if I look on top view, these two shafts stops at the same exact distance, so I like this, and then I'll confirm and finish. So this shaft cannot move anywhere, and the whole mechanism can rotate. What I can do now is adding the second pulley. So the second pulley, it has a name, number 10, which is saw pulley. Components, the saw pulley, and then I can bring it close to the shaft, mate cylinder with cylinder, and if you remember, I have to take it out to some specific distance, or simply I can say that this edge is mated with this edge, and that's it. So the two pulley systems are connected now, and the whole mechanism can rotate. Now let's go and bring the cover. So this cover, number 11, is covering the saw, and it's connected to this blade through these small L shapes. So number 11 is the cover. I have to go and find the cover number 11, which is this one, open, and you can see that it has two sides, one of them with the L shapes to be connected on the blade, and one of them to connect the saw and the nut. So I have to say that, of course, I can rotate the component to make it easier for me to imagine the mate, and then I will rotate until I get to reach hole numbers 1 and 2 to be connected in here, and 3 and 4 in this side. So simply I can go to mate, that edge with this edge for blade number 1, and you can see that if I connect any other edge, I will fix the cover with the blade. So let me go and select this. So I'll say edge number 1 on the cover with edge number 2 on the blade, and that's it. So the cover now is connected. Good. What about the saw itself? So simply I will add the saw, and easily I can say mate the center of the saw with the center of this shaft. Now you can see that if I look on the front view, now this saw can move in the same axis of the shaft, and then I have to stop in a specific location. Of course, if I stop in this position, there is no point of the cover, so the saw should go inside the cover. But I cannot stop in one side and leave some space in the other side, so it should be something in between. So the saw should go somewhere in between, something like this. Of course, if I want to be accurate, I have to measure the distance, the available distance, and then create a mate between the surface of the saw. Let me just go and mate this surface of the saw with that surface of the cover, so they are attached to each other now, and then I will create a distance, and let me try 0.6, that's too much, maybe 0.4. Of course, if I measure the distance, I will just put it exactly in the middle, so 0.4, that's good. So if we check the front view, you can see that the saw will not touch any side of the cover. And finally, we have to fix the saw on the shaft by closing the nut. If I insert components and find the nut, open, and that's easy. Mate cylinder with cylinder, and then surface with surface, and I can give it like 0.1 distance or 0.2 centimeter to make sure that it's touching the saw and it's fixed. I can see that still we have small distance, but this is only an approximate drawing, and then we can finish. Now, I think we have done the assembly. Let me check the whole view, the isometric view, and this mechanism is going up and down. And remember that I fixed the rotating blade in order to get the freedom to make the components. Now, if I float this, right click and float, you can see that I can rotate this in multiple angles, and at the same time I can move the saw up and down. Okay. Now I think I'm missing only one single component, which is the holder of the blade, because the operator of the saw cannot hold the pulley or the cover or the saw itself, so I need something in here to make it easy for him to hold the mechanism, which is the part number 14, the holder. So we have to bring that holder. Yes. And how it's attached, let me check the PDF file. This one. So it's attached to one side of the blade. So if I rotate this, yes, this is the proper location. Good. So I have to mate top surface of the blade with this surface, confirm this surface with that surface, confirm, and this surface with this surface, and confirm, and finish the mate. Good. So if I hold the saw mechanism from this holder, I can move it up and down, and if I hold it from this holder, I can rotate the angle. And that's it. We are done with the assembly, and we fixed the whole view, and things are perfect. So this will be the end of part 1 of tutorial 10, and in the second part we will learn how to make the exploded view, how to make animations to automatically rotate the saw mechanism, and how to make 2D drawings of the parts and the assembly, how to make the bill of material, that table we had in the PDF, how to make the balloons, the icons, the numbers indicating each part, and how to develop their table with quantities, part numbers, and everything. So that's it. Thank you for watching the video.